Have you ever wondered how your internet reaches your device or how your computer connects to another one? Behind the scenes, there are some smart devices doing all the work. In this video, let's explore important network devices like RJ45 connector, Ethernet card, NIC, modem, router, switch, hub, bridge, gateway, repeater, Wi-Fi card, with simple examples. Let's get started. Let's learn about the RJ45 connector. RJ45, registered Jack 45, is a standard plug mainly used for Ethernet networking. Ethernet networking is a wired system that connects devices in a local area network, LAN, to share data reliably and quickly. Originally designed for telephones, now used for high-speed digital data transmission. Has 8 metal contacts connected to 4 twisted pairs of copper wires that reduce interference. Works with Ethernet speeds from 10 megabits per second to 40 gigabits per second depending on cable type. Compatible with Cat5, Cat5e, Cat6, Cat6a, Cat7, and Cat8 cables. Uses T568A or T568B wiring standards. Let's see the features of RJ45 connector. 8 pins, each pin connects to a specific wire pair to transmit and receive data efficiently. Modular design fits universally into devices like computers, routers, switches, and network ports. Clip lock mechanism. A plastic clip clicks when plugged in, securing the connection, press to release. Gold-plated contacts, provides good electrical conductivity and prevents rust, ensuring a stable signal. Durability, designed for repeated use without breaking or losing signal quality. Color-coded wiring, helps technicians connect wires accurately and avoid errors during installation. Let's see the function of RJ45 connector. Physically connects a computer or device to a wired network, router, switch, or modem. Works like a charging pin for your device. Without it, no wired internet connection is possible. Let's see the applications of RJ45 connector. Computer networks, connects computers, servers, and switches for fast and reliable data transfer in offices and data centers. Internet connection, links routers, modems, and devices, like smart TVs and consoles, for faster, more stable wired internet. Phone and communication systems, used in VoIP phones, transmitting voice through Ethernet cables for flexible office setups. Audio and video signals, carry sound and video in systems like HD-based or IP-based HDMI, ideal for theaters and meeting rooms. Security cameras, connects IP cameras with PoE, power over Ethernet, to send both data and power through one cable. Home networks, links home devices like PCs, printers, and game consoles, providing faster, lag-free internet than Wi-Fi. Industrial use, used in factories to connect machines and sensors, designed to withstand vibration, moisture, and interference. Here is a fun fact. RJ45 looks like a telephone connector, RJ11, but is wider and has 8 wires instead of 4 or 6. To attach an RJ45 connector to a cable, strip about 1 inch of the cable's outer jacket. Untwist the 4 wire pairs and arrange them by color according to T568A or T568B. Keep the twists as close to the connector as possible to reduce interference. Trim the wires to the same length, about ½ inch. Slide them into the connector, ensuring each one reaches its pin and the sheath fits inside the rear of the plug. Use a crimping tool to press the connector's metal contacts into the wires and lock the plug. After crimping, test the cable using a network tester to ensure all wires are correctly connected and the signal is clean. We just learned about the RJ45 connector, the plug that connects your Ethernet cable to your computer or router. But have you ever wondered what happens next? How does your computer actually communicate with the network once that cable is plugged in? That's where the Ethernet card, also known as the Network Interface Card, or NIC, comes in. Think of the Ethernet card as the SIM card of your computer. Just like a SIM card connects your mobile phone to the network. The Ethernet card connects your computer to a local network or the internet. Note that in the image, all the devices, both computers, the router, and the modem have network interface cards, NICs. What is an Ethernet card, NIC? A network interface card, or NIC, is a small piece of hardware. That means it's a physical part of your computer. That allows your device to connect and communicate with other devices on a network. It acts like a bridge between your computer and the network. Without it, even if you have a cable connected, your computer can't talk to other devices or access the internet. Where is the NIC located? In older computers, the NIC was a separate card plugged into the motherboard. But today, most computers and laptops come with a built-in NIC. Still, there are other forms too. Like USB NICs for portable use, a small, portable USB LAN adapters that you can plug into laptops or desktops to add or upgrade wired Ethernet connectivity, especially handy where built-in LAN is missing or slow, and fiber optic NICs for super-fast data transfer, These are high-performance NICs designed for fiber optic connectivity, SFP or SFP+ ports, PCIe cards, used in servers, workstations, or high-speed infrastructure. Let's see the types of NIC. NICs can be of different types based on how they connect to the network. Wired NIC uses Ethernet cables for connection. Wireless NIC connects using Wi-Fi signals. USB NIC, portable and connects via a USB port. Fiber optic NIC uses light signals for high-speed internet. Let's see the main components of a NIC. Processor. Works like a mini brain that handles data transmission. Memory stores data temporarily while sending or receiving. Connectors let the NIC connect to network cables or Wi-Fi antennas. MAC address. A MAC address, Media Access Control Address, is a unique hardware identifier. Assigned to a network interface card, NIC, for communication on a network. Example, 00:1A, 2B, 3C, 4D, 5E. Driver, a small software that helps the computer communicate with the NIC. On your laptop, open Settings. Then select Device Manager. Then click Network Adapters to see which driver your system is using. Speed, NICs can transfer data at different rates, like 10 megabits per second, 100 megabits per second, or 1 gigabit per second, depending on their type. LED indicators show when data is being sent or received. Let's see how the NIC works. Your computer understands everything in digital form. That means all the websites, videos, and messages are just ones and zeros, called binary data. The NIC's job is to convert this digital data into signals that can travel through the network. If you're using an Ethernet cable, the NIC turns the digital data into electrical signals that move through the copper wires. If you're using Wi-Fi, the NIC converts that same digital data into radio waves that travel through the air. These signals go through your router, reach the web server, and bring information back to your computer. Example, visiting a website. Let's say you type a website address, like www.example.com, and press enter. Here's what happens step by step. Step 1. Your browser sends the request to the NIC. Step 2. The NIC changes your computer's digital data into network signals. Step 3. Those signals travel through your router, across the internet, and reach the web server. Step 4. The server finds the website content and sends it back as signals. Step 5. Your NIC receives those signals and translates them back into digital data. Step 6. Finally, your browser displays the web page on your screen. So, the NIC is constantly sending and receiving data, acting as your computer's communication translator. NIC and software connection. But wait, how does your computer's software talk to the NIC hardware? That's the job of a small program called a driver. The driver acts like a translator between your operating system and the NIC. It tells the NIC how to send and receive data properly. Think of it like this. Your computer speaks English. The NIC speaks Morse code. And the driver is the interpreter who makes sure both can understand each other perfectly. Functions of a NIC. It acts as a bridge between your computer and the network. It enables data transfer and internet access. It allows your computer to communicate with other devices on the same network, LAN. Let's see a fun fact. Did you know? Big servers often have multiple NICs to handle heavy network traffic. While your laptop usually has one built-in NIC for Ethernet and another for Wi-Fi. What is a Wi-Fi card? A Wi-Fi card is a wireless network adapter, either internal or external, that allows a computer to connect to a Wi-Fi network without using any cables. It contains a built-in wireless radio and antenna, enabling your device to detect and communicate with nearby wireless routers or access points. Let's see the function of Wi-Fi card. It provides wireless communication between your device and the network. It eliminates the need for Ethernet cables. It enables internet access through Wi-Fi. It works using Wi-Fi, wireless fidelity, technology, hence the name Wi-Fi card. Think of a Wi-Fi card like ears for your computer. Just like ears help you hear sound, a Wi-Fi card helps your computer hear wireless signals in the air and connect to the internet, no wires required. Let's see the types of Wi-Fi cards. Internal Wi-Fi cards. Installed directly on the motherboard. For example, PCI Express Wi-Fi cards, common in desktops. External Wi-Fi cards. Plugged in via USB ports, portable and easy to install. Where is Wi-Fi card used? In laptops. Built-in for easy mobility. In desktops. Installed internally or via USB dongles. In tablets and other smart devices. Integrated wireless capability. It's especially useful in notebook computers, where portability and wireless access are a must. Let's see a fun fact. A Wi-Fi card doesn't just receive wireless signals. It actually converts invisible radio waves into digital data your computer understands, acting like a mini radio station inside your device. What is a repeater? A repeater is a network device that regenerates weak signals so they can travel longer distances without getting lost. It does not change the data, it only rebuilds and forwards the signal at its original strength. A repeater operates at the physical layer, layer 1, of the OSI model. Why do we need a repeater? When data travels through a network cable, it moves as electrical signals that gradually lose strength over distance. This weakening is called attenuation. In many Ethernet standards, signals remain reliable only up to about 100 meters of cable. If the signal becomes too weak, the data will not reach the next device properly, causing errors or loss of communication. A repeater is used in such cases to restore the weakened signal so it can continue to travel further reliably. How does a repeater work? A repeater is placed in the network before the signal becomes too weak. Here's what it does. First, it receives the weak or distorted signal. Then, it regenerates the signal by reconstructing the original bits and restoring their timing. Finally, it sends the strong, clean signal forward. This helps the data continue its journey clearly and smoothly, ensuring reliable communication over longer distances. An important point to remember, a repeater does not analyze or modify the data, it only works at the physical layer, making it a simple device that copies and forwards every bit it receives. This means it does not filter, process, or change the information in any way, it just makes sure the signal stays strong and clear as it travels across the network. What does a repeater do? In simple words, a repeater boosts weak signals, restores them to their original strength, helps signals travel longer distances, connects two similar network segments, keeps the communication clear and reliable. Remember, it doesn't modify the data, it only strengthens and regenerates the signal. Here's an easy way to remember it. Think of a repeater like a mobile signal tower. When your phone signal becomes weak, the tower regenerates and boosts it so your call doesn't get disconnected. A repeater does the same thing, but for network signals, it regenerates and forwards the signal so data can travel further without errors. Where are repeaters used? Repeaters are used in many places. Long Ethernet cables that go beyond 100 meters. Wi-Fi range extenders to boost wireless signals. Broadcasting systems for audio and video signals. Rural areas where signals are weak due to distance. Large buildings to maintain good network coverage. Fiber optic networks to extend the reach of signals over long distances. Industrial networks to connect segments that are far apart. Anywhere a signal needs help, a repeater is there. Repeaters are essential in any situation where signal attenuation would otherwise limit communication reliability. Let's see the key features of a repeater. Repeaters usually have two ports, one to receive the signal and one to send it out. They don't analyze or filter data, they only repeat and regenerate the signal. They work in both wired and wireless networks. A repeater operates at the physical layer, layer 1, of the OSI model, so it does not modify or process the data in any way. It is used to extend the physical reach of a network segment and maintain signal integrity over longer distances. Let's see a fun fact. A repeater can turn a weak, unclear signal into a brand new, clean signal. So sometimes, the signal coming out of a repeater is actually stronger and clearer than the one that went in. This regeneration process helps prevent data loss and ensures reliable communication, even over long distances. What is a hub? A hub is one of the oldest and simplest networking devices. It connects multiple computers or devices in a network so they can communicate with each other. Think of a hub like a microphone in a room, whatever one person says, everyone hears. That's exactly how a hub works. What does a hub do? A hub receives data from one device and sends the same data to all other devices connected to it. It does not check who the data is meant for, where it should be delivered, whether the data is safe, whether the device is busy or not. It just broadcasts the data to every device. Let's see how a hub works with 4 computers. Suppose computer 1 wants to send a message to computer 4. Computer 1 sends the data to the hub. The hub does not read the destination address. It simply copies the data to all its ports. So the data goes to computer 2, computer 3, and computer 4, even though the message was meant only for computer 4. All computers receive the data, but only computer 4 accepts it. The other computers just ignore it. Why is this a problem? This send-to-all behavior of a hub causes several issues. First, it leads to low speed because all devices connected to the hub share the same bandwidth. Second, it creates more collisions. When two devices send data at the same time, the data collides and must be resent, which slows down the network even further. Finally, a hub provides no security since every device receives everyone else's data, making it unsafe for modern networks. Let's see the types of hubs. There are two main types. Active hub has power, boosts or amplifies signals, works like a simple repeater plus hub. Passive hub does not amplify signals, only distributes signals, works like an extension box. Is hub still used today? Not really. Hubs are almost obsolete because they are slow, 10 to 100 megabits per second, they cause collisions, they are not secure. Switches have replaced hubs because they are faster, smarter, and more secure. Where were hubs used earlier? Small home networks, small offices, computer labs in early 2000s, when data traffic was low and security was not a big concern. Let's see a fun fact. A hub works at layer 1, physical layer, of the OSI model, the same layer as cables and connectors. That's why it does not understand MAC addresses or make decisions. What is a bridge? A bridge is a networking device used to connect two or more LAN segments. Think of a bridge like a traffic police officer standing between two roads. It checks who should go where before letting data pass. Unlike a hub, which sends data to everyone, a bridge is smart enough to send data only where it is needed. What does a bridge do? A bridge receives data from one side of the network, reads both the source and destination MAC addresses, and decides where the data should go. Which device should receive it? Whether to forward the data or block it. It filters traffic by building and maintaining a MAC address table. This keeps the network faster and cleaner by reducing unnecessary traffic. Let's see, how does a bridge work? Imagine two LAN segments, segment A with computer 1 and 2, and segment B with computer 3 and 4. If computer 1 sends data to computer 3, the bridge receives the frame, looks up computer 3 in its MAC table, sees that it is on segment B, and forwards the frame only to segment B. But if computer 1 sends a message to computer 2, both are in segment A, the bridge will not forward the data. It keeps the communication inside segment A only. This reduces traffic and keeps the network faster. If the bridge does not yet know the destination MAC address or if the frame is a broadcast, it temporarily floods the frame out all ports except the incoming one, learns from the replies, and then updates its MAC table for future decisions. Why is a bridge better than a hub? A bridge does not broadcast to everyone like a hub. Instead, it learns which devices are on which side by observing source MAC addresses. Filters unnecessary traffic. Reduces collisions. Improves network efficiency. This makes a bridge smarter than a hub because it works at the data link layer, layer 2, of the OSI model. Let's learn the types of bridges. Transparent bridges, used in Ethernet networks. Learns MAC addresses automatically. Most common in modern networks. Source routing bridges, used in token ring networks. The sender decides the path. Mostly outdated today. Where are bridges used? Bridges were commonly used in early LAN networks. Dividing large networks into small segments. Reducing unnecessary traffic and avoiding congestion. Connecting two floors or departments of a building. Today, bridges are rare because switches have replaced them. Switches are faster, smarter, and more efficient. But bridges are important to understand because switches were originally designed as multi-port bridges. Let's see a fun fact. A bridge works at layer 2, data link layer, of the OSI model. This means it understands MAC addresses, unlike hubs that only work at layer 1. What's a switch? A switch is a networking device that connects multiple computers or devices inside the same local network, like in a school lab, office, or even a smart home. If a router connects networks, a switch connects devices inside a network. Think of the switch as a classroom teacher who knows every student's name and gives the correct assignment to the correct student. Why do we use a switch? We use a switch when we need many computers to be connected, we want to share files, printers, and resources, we want the network to be fast and organized. Routers usually have 2 to 4 ports. Switches have 8, 16, 24, or even 48 ports, so they are used when many devices must be connected. What does a switch do? Let's learn the functions of a switch. A switch performs 3 major jobs. Connects multiple devices. It lets computers, printers, IP cameras, and servers exist on the same local area network, LAN. Learns MAC addresses. Every device has a MAC address, like a roll number. The switch studies these MAC addresses and remembers which device is connected to which port. This is called the MAC address table. Sends data to the right device. When a device sends data, the switch checks the MAC address table, sends the data only to the correct device, not to everyone. This makes the network faster, more secure, less congested. Let's say you have 6 computers, and you want them to communicate with each other. For example, computer 1 needs to communicate with computer 6, or computer 2 needs to connect with computer 4, and so on. This is where a network switch comes in. A switch allows multiple computers in the same network environment, such as a home or office, to communicate efficiently. Each of these 6 computers connects to the switch using Ethernet cables, enabling seamless data exchange within the network. A switch cannot use wireless technology. If you want the devices in the same environment to be connected to each other over wireless technology, you should use an access point device. By using the switch device or access points, we can create a network called the Local Area Network, LAN. LAN is a network that connects devices within a limited area, like your home, school, or office. It ensures fast communication and resource sharing. A switch device has multiple ports, which are also known as LAN ports. Similar to switch LAN ports, there are LAN ports on the back of desktop computers and on the sides of laptops. To establish a connection between a computer and a switch, we connect the LAN port of the computer to the LAN port of the switch using an Ethernet cable. Once connected, computers can communicate with each other through the switch. You can specify the type of Ethernet cable used, such as twisted pair cable, for example, Cat5e, Cat6, Cat7, commonly used in LAN connections. Fiber optic cable, used for high-speed networking and longer distances. Now let's see how the switch works. A switch is an intelligent network device. For example, suppose computer 1 wants to send a data packet to computer 4. The data packet starts from computer 1 and enters the switch. The switch then learns and stores the MAC addresses of connected devices in a table, mapping them to their corresponding port numbers. If the switch has already learned computer 4's MAC address and its associated port, it directly forwards the packet to the correct port, computer 4. What is a MAC address? A MAC, Media Access Control, address is a unique identifier assigned to a device's network interface card, NIC. It helps in communication within a local network. It is 12-digit hexadecimal number. For example, 00:A0:C9:14:C8:29. It is used by switches to forward data packets to the correct device in a LAN, local area network. Network interface card is a hardware device that connects a computer or network device to a communication network. It contains the MAC address and helps devices send and receive data over a network. It is either wired, Ethernet, or wireless, Wi-Fi adapter. Let's learn the types of switches. Unmanaged switch. An unmanaged switch is a simple plug-and-play device that requires no configuration. It is commonly used in homes or small offices where basic network expansion is needed. Managed switch. A managed switch can be configured based on your network needs. It supports features like VLANs and traffic control, making it suitable for schools, colleges, and companies. PoE switch, power over Ethernet. A PoE switch sends both power and data through the same Ethernet cable. It is used to connect devices like CCTV cameras, Wi-Fi access points, and IP phones without needing separate power adapters. Where are switches used? Switches are used in school computer labs, offices, data centers, server rooms, CCTV networks, smart buildings, any place where many devices need to connect in a LAN. Let's see a fun fact. A switch can handle thousands of MAC addresses and can forward data in microseconds, faster than a blink of an eye. Most modern routers actually have built-in switches. That's why your Wi-Fi router usually has 4 or more LAN ports at the back. What's a router? Think of your modem as the water tank that brings water, internet, into your home, and the router as the pipes that distribute that water to every tap, your devices. If the modem brings the internet inside, the router spreads the internet to all your laptops, phones, TVs, or tablets. A router is a networking device that connects multiple networks and forwards data between them. It uses IP addresses to decide the best path for data to reach its destination. A router is the traffic manager of your network. It connects multiple devices to the internet and also lets them communicate with each other inside a home, school, or office. Why do we need a router? We need a router because we don't want just one device to use the internet, we want Wi-Fi, we want all our devices to communicate safely, and we need security features like firewalls and passwords. A router also allows us to share files, printers, and screens across the network. Without a router, the modem would provide internet to only a single device. What does a router do? Let's learn the functions of a router. A modern router performs 4 major functions. First, it distributes the internet by taking the connection from the modem and sharing it with all devices through Wi-Fi and LAN, RJ45, ports. Second, it assigns IP addresses to every device in the home using DHCP, ensuring each device, like a laptop or mobile, gets its own unique local address so the router can identify them. Third, it routes data by deciding where information should go, which device requested a web page, and which device should receive the response. This intelligent path selection is called routing. For example, packet handling. Data on the internet is broken into packets. If these packets need to pass through another network that cannot handle large packets, the router repackages, fragments, them into smaller packets so they can travel smoothly. This ensures proper communication between different types of networks. Finally, the router provides security through features like passwords, firewalls, blocking unwanted traffic, and guest networks, helping protect all devices from threats. Let's see how a router works. The modem first receives the internet from your ISP, and the router connects to the modem using a LAN cable. The router then broadcasts Wi-Fi signals, and your devices connect to it. The router assigns each device an IP address, and when you open a web page, the router sends the request to the modem, which forwards it to the ISP, and the ISP sends it to the website's server. The response travels back the same way, from the server to the ISP, then to the modem, then to the router, and finally to your device. Let's see the types of routers. Single-band routers work only on the 2.4 GHz Wi-Fi band. They offer slower speeds but have a longer range, making them suitable for small homes or basic internet usage. Dual-band routers support both 2.4 GHz and 5 GHz bands. They provide faster speeds, less interference, and are the most commonly used routers in homes today. Mesh Wi-Fi routers consist of multiple units placed around the house. They work together to provide seamless, whole-home coverage, making them the best choice for large homes with Wi-Fi dead zones. Modem-a-router combo devices combine the functions of a modem and router into a single unit. These are commonly used in fiber or cable internet connections to simplify setup and reduce the number of devices. Routers are used everywhere the internet is shared, such as in homes, schools, colleges, offices, cybercafes, hotels, and airports. In fact, almost anywhere you find Wi-Fi, there is a router working behind the scenes to connect devices to the internet. Let's see a fun fact. A router can handle hundreds of websites at the same time because it uses a technique called NAT, Network Address Translation, which allows all the devices in your home to share one single public IP address. What is a modem? A modem, short for modulator-demodulator, is the translator between your computer and the internet. It's an electronic device that establishes and maintains a connection with your internet service provider, ISP, so you can access the internet. Now, why do we need a modem? Because computers use digital signals, ones and zeros, and in earlier times, communication lines like telephone lines carried analog signals. So, the modem's job is to convert between digital and analog, allowing smooth communication between your computer and the internet. Let's see the function of a modem. A modem performs two main functions. Modulation. Converts digital signals from your computer into analog signals, like sounds over a telephone line, for transmission. Demodulation. Converts incoming analog signals back into digital data so your computer can understand them. This two-way process is what gives the modem its name. Modulator plus demodulator equals modem. This image shows how a modem worked in the old days, using telephone lines to send digital data between two computers through modulation and demodulation. Let's walk through it step by step. On the left, the sending computer. The computer works with digital signals, binary zeros and ones, square wave shown in red. But telephone lines cannot carry digital signals directly, they transmit analog signals, smooth waves. The modem near the sending computer. Modem stands for modulator, demodulator. Here it acts as a modulator. It converts, modulates, the computer's digital signal into an analog signal so it can travel over the telephone line. In the middle, the telephone line. This carries the analog signal between two locations. The wave shown in blue represents how data looks as an analog waveform while being transmitted. On the right, the receiving modem. When the analog signal reaches the destination, the modem demodulates it. It converts the analog signal back into a digital signal so the receiving computer can understand it. Also works in reverse, the process happens both ways, each modem can modulate outgoing data and demodulate incoming data, hence the red, modulation, and green, demodulation, arrows in both directions. Back then, the connection speed was very slow, around 56 kbps, and you couldn't make phone calls while using the internet. Let's see how a modem works today, modern internet. Today, most connections use broadband, fiber, or wireless systems. Modern modems don't have to deal with analog telephone lines anymore, everything is digital. Depending on your internet type. Cable modems use coaxial cables, the same cables used for TV. They convert digital data from your ISP into signals your router or computer can use. DSL modems use upgraded telephone lines but transmit digital data on higher frequencies, so you can talk and surf at the same time. Fiber modems, ONTs. In fiber connections, light carries data. The device that connects your fiber cable is called an optical network terminal, ONT. It works like a modem but converts light signals to digital data. 4G per 5G modems. Found inside smartphones and wireless routers, they communicate with cell towers using radio waves. Modern modems are much faster and often come combined with routers. We call these gateway devices. Let's see the types of modems. Dial-up modem, use telephone lines, oldest. DSL modem, uses digital signals over phone lines. Cable modem, uses coaxial cable, used in homes. Fiber modem/ONT, uses light signals over fiber. Wireless or cellular modem, uses 4G per 5G or Wi-Fi. Let's see where a modem is used. In homes and schools to connect routers or computers to the internet. In offices, banks, and data centers where stable internet is needed. Inside mobile phones and IoT devices, mini modems help them communicate online. Let's see a fun fact. Did you know? The first commercial modem was introduced in the 1960s by AT&T and was used by the US military. Old modems made a funny screeching sound when connecting. Those were the digital handshakes over telephone lines. Today's fiber modems can be millions of times faster than the old dial-up ones. What is a gateway? So, imagine you have two different networks, say, your home Wi-Fi and the internet. These networks often speak different languages or use different rules. That's where a gateway comes in. It's like a bridge that connects two networks, especially when they don't understand each other right away. A gateway is a network device that connects two different types of networks, especially when those networks use different communication protocols. It acts as a translator or converter, helping two dissimilar networks understand each other and communicate effectively. What does a gateway do? It connects your local network, like your home or office, to the outside world, such as the internet. It acts like a translator, changing data from one format to another so both sides can understand each other. It also controls the flow of data, acting as the main door for anything coming in or going out of your network. Some gateways even help keep your network safe by filtering traffic or acting as a firewall. Imagine a gateway like an international airport. You leave your local country, LAN, and enter a foreign country, external network. The gateway is like immigration and customs. It checks, translates, and lets you pass through safely and in the right format. Why do we need gateways? The internet is made up of many different types of networks, each with different structures and protocols. A gateway ensures reliable communication by handling these differences and making data understandable to both sides. Where do we see gateways? When you connect your home or office network to the internet. In voice over IP, VoIP, calls, where your voice is turned into data and sent over the internet. In cloud services, where your local network connects to remote servers. Anytime two different networks need to communicate, a gateway is probably involved. Let's see a real-life example. When you open a website, your computer first sends the request to the gateway. The gateway then forwards that request from your local network out to the correct server on the internet. When the website's server replies, the response comes back through the internet to the gateway, and finally from the gateway to your computer, in a format your computer can understand. Let's see a fun fact. Gateways are special because they can work across several layers of networking, something regular devices like hubs, switches, or routers can't do. This lets them translate completely different protocols, making them super versatile. Thanks for watching. If you found this video useful, like, share, and subscribe to Sally and Bytes for more tech made simple. See you in the next video.